Okay, good afternoon and welcome back to this course. Today's session is an extension of decision trees which we discussed in the previous session. Decision tree is a supervised learning technique which we discussed sufficiently as a part of understanding classification. Okay. So, decision tree can be used to build classifiers and then you can test it for its performance and use it for solving problems. Okay. So, the aim of today's class is to discuss an application of decision trees which is a part of the readings that is given to you. So, you can look at the description of the case that we are going to use today for decision trees. The case is titled Adventure Works Targeted Mailing. So, the case talks about a cycle manufacturing company or bicycle manufacturing company. In the West it is called bike. Okay. So, when we hear the term bike, we generally expect that it's a motorbike, but that's not the case if you go to Europe or America. So, bike is a cycle for us and this company actually is a manufacturing company and it also has distribution networks and marketing channels and it also sells online. Okay. So, and this company also has developed analytics as a practice and therefore it has built infrastructure, okay, which we discussed, like data warehouse and tables which capture relevant data from databases and store in the data warehouse for data analysis purpose. Okay. So, one of the files that they have captured in the data warehouse is the bike buyer table. Okay. It is a table basically. The bike buyer table I have downloaded from the database of this company, this fictitious company, and converted that into a CSV file. Okay. So, in the CSV file you will find, if you open bikebuyer.csv, so I suggest that you open this file bikebuyer.csv which is there in the data folder. So, this is the data source, okay, or this is the data that we are going to use today. Okay. So, what is given to us is a targeting problem, okay, a problem which we have been discussing a lot without any data, but today we are going to use some data and model it. Okay. So, in targeting, the main decision is, well, you have a larger data set of potential customers, but you do not have all the money to go after everyone. Okay. So, it's not required, you have to be very targeted or focused in your approach so that you spend your money and time wisely. So, therefore, from the larger database you decide whom to target, okay, based on your budget. That is the targeting problem. Okay. So, and a target whom you target or whom you reach out to should be relevant or responding target, a target who is likely to respond. Okay. So, if you reach out to people who are not going to buy your product, you are wasting your resources. So, that is the problem in targeting. Whom should you target, whom should you reach out to. Okay. So, what we have to take this decision is a lot of attributes about the various target potential targets or the different elements in the database or different prospects in the database. You have their characteristics as well. It is not just their address or name, but certain attributes of the customers, potential customers are also given. So, here for example, if you look at the Adventure Works database, you can see that each record has an identifier or a primary key which is the customer key, and then certain attributes of that particular customer. Okay. So, what are those attributes? It talks about the marital status. You can see single M, S or M. Okay. So, looks like a binary, okay, nothing in between, of course. And the second attribute is yearly income. you can see it's a numeric data, and total children at home, so you can see it's a number, okay, it's an integer, it's a count, okay. And next attribute is children, total children, that is one attribute, children at home, both are different, right. So both the attributes are captured. House owner, in the sense whether the particular prospect owns a house or not, and number of cars at home, age. So when we discussed data warehouse, when we discussed viscosity score as a problem, we recognize that these are problems related to variable selection, okay. You select certain variables for a problem, okay. So you select variables such that one, data about those variables are available, and number two, they are good predictors of a certain behavior, okay, certain outcome which you want to model. And here the outcome is what? There is a last column which talks about bike buyer, okay. So bike buyer is a binary variable, you can see 0 or 1, okay. 1 means this particular person has bought a cycle in the past, okay, and 0 means this person has not bought a cycle, okay. Therefore the variable of interest or the target variable is the bike buyer variable, and it has two values or two labels or two classes, okay, all are the same, okay. This is a two class variable, 1 and 0, okay. 1 is a buyer, 0 is a non buyer, okay, and that is what we are interested in. So here in this case we are interested to know what rules determine A1, okay, or what conditions lead to an outcome which is 1, okay, and that is something that you want to use to predict future potential buyers, okay. So this is historical data, but from this, if you have a new set of customer data that you obtained, you want to target them based on the rules that you will develop from this data, okay. That is what we are doing. So a decision tree helps us discover the rules, and then we apply that to a new set of data, that is prediction, okay. So that is the problem that we are going to address in today's class, okay. So in order to do this, we are going to employ Python programming, okay. So I am sure you are all trained in Python to some extent, and if not, you are getting trained and you are soiling your hands and having some fun, I believe. So you started with Hello World, and I am sure I have referred a textbook to you which is very much a textbook related to Python for data science, okay. This McKinney's book is something I strongly recommend. I use that book to learn Python for data science myself. So please do refer and sit with your programming platform, whether Anaconda or Google, whatever you want to use. You can use Google platform for the same purpose. I will be using Anaconda. So let me actually open Anaconda Navigator, okay, and the Jupyter Notebook, okay. Help us run the code from the browser. Of course, the Jupyter Notebook is an interface to write the codes, and you write it cell wise, okay, or it is very modular, okay. So you can write related instructions together and execute it. So the first effort is to call the relevant libraries, okay, or to invoke the libraries so that the functions in the libraries can be called, okay. So the first step is that I am invoking certain libraries which are already existing, okay. So which is the library that I am extensively using here? In addition to the generic instructions that are available in Python, I am importing a set of functions from a library known as scikit-learn or sklearn, okay. sklearn is a library, okay, which was developed, I guess, by Google. It was a summer project of some students. So it is an open source, okay, it is an open code which has several useful functions of machine learning, okay. So it has already coded machine learning algorithms and functions, and you can directly import them and use them. Okay, so sklearn means scikit-learn. Okay, and scikit-learn library also comes with extensive documentation. Okay, in your assignment you must be referring to scikit-learn documentation, and I have given you specific references for that. So we are going to use that. Okay, the first thing I am doing is I am importing the tree, because we are going to build decision tree. The first one would be the cart algorithm, and I am also using decision tree classifier because I want to look at how the decision tree has performed with the test data. Okay, so that is a separate function I am actually importing. Then I am importing train test split. Okay, that is actually a function available in the scikit-learn model selection. So this is actually for splitting the data set into train data and test data. We discussed about it. And stratified k-fold is the it gives the function for k-fold cross validation. Okay, k-fold cross validation. And then there is another library, scikit-learn metrics, and the confusion metrics, or different measures that are used to evaluate classifiers. That's all developed in a library known as metrics. Okay, so confusion metrics is one of them. Okay, so I am importing that. Export graph is actually this is useful for visualizing the graph. Okay, and then in addition to scikit-learn functions, okay, it's all mixed up here when I call them. I am using pandas. I hope you are learning pandas, already have learned pandas already, numpy and pandas. Numpy basically for arrays or algebraic operations, pandas for the data frames. Okay, you can actually work with tables of different columns having different data types. Okay, that is a data frame. Okay, so if you have to call a table data with multiple data types and work on them, you need a data frame. Okay, pandas provide that. Okay, numpy, and the graph is, as I said, is for visualization, and matplotlib is also for visualization. Okay, so graph is developed specifically for decision tree visualization, and matplotlib is a very generic library for different types of graphs. Okay, and I am also calling functions for random forest classifier, and a function for bootstrapping. You can see my classification, and k-fold is already done. Okay, all right. So let me execute this. Depending on whether you are using Windows or Mac, you have shortcuts, different shortcuts for execution. Of course, at the top you find a run. So when you are in a particular cell, you will be running the codes in that cell. Okay, so all the calls are fine. So all these libraries and their corresponding functions have been imported to the Jupyter Notebook platform, and we are going to use those functions now. Okay, now in the second cell, yes, you have to install it separately. You have to install it separately. The procedure is given in your course outline. Okay, that has to be installed separately. Okay, it will not come if you haven't done. You run some code to do that. Okay, now next is we are going to read the data. In our case, the data pertains to a problem of bike buyer. Okay, so targeting bike buyers. Okay, that is our problem. We looked at the data already. So you can read the data from the folder where you have stored that data by providing the path here. That is one way. Or if you upload the data into the Jupyter folder, which we saw previously, you don't have to give all this path, but you can just use the file name. Okay, the file name is bikebuyer.csv. Okay, so that is the first instruction, and you can see that I am reading it as pd.csv. read CSV. Okay, read CSV is a function in pandas, and it gets read as a pandas data frame, meaning it functions as a multi data type table. Okay, so I can access different columns although their data types are different. Okay, and now I need to extract I have to separate my data now into target data and X data. Okay, your predictors and target. Okay, so the attributes and the target variable. So X is the attribute data set or the attribute variables. Okay, and what does my X consist of? I am going to use, we have seen these labels already, right? I am going to use yearly income, total children, children at home, house owner flag, number of cars owned, and age. Okay, these are the variables I am going to use as the X data. Okay, as the attributes. So I am defining that particular data frame. Okay, data is already a data frame in pandas, so that particular data frame is defined as X. Okay, X is equal to from data I am extracting these variables. Okay, and if you want to see what is the type of X, you can actually look at here. I can just execute it here. Okay, it's a pandas code data frame. Okay, so just to be sure about it. Okay, okay, and shape, actually, you know, you must be familiar. Shape provides the dimensions of the table. So it is 6 variables or 6 columns, and how many records? How many records? 18,484 records or rows or tuples. Okay, 18,484 tuples, fairly decent size of data, and 6 variables or 6 attributes. Okay, that is a shape. Okay, and what are the data types? Okay, the data types of different variables are given here based on the auto identification done. Okay, on the data. Okay, all the data is identified as integers. Okay, and now you can see I have put a comment there, marital status not included. I did not include marital status in my attribute list, and there is a reason for it. Okay, and that is a limitation. Okay, so when I am going to use the CART algorithm, okay, the particular version of the algorithm I am using, it does not support categorical variables. That is a serious limitation, and if I give categorical variables and label them as 1, 2, 3, etc., the algorithm will take it as a numeric variable. Okay, and that will lead to problem. Okay, it is actually not a numeric variable, so it will do calculations on categorical data and so on. So in order to avoid that, I am just dropping that variable. I do not want a categorical variable. Okay, others are either interval variables or ordinal variables. We can still use them, but categorical I am avoiding. But you are smarter than me in coding. Do explore scikit-learn or any other library where you can find algorithms that will support all kinds of data. Okay, here there is a limitation. Okay, and I want to see that in your assignment. Okay, and the last one, okay, it will that X head dot head is very interesting because it gives you a sense of how the data looks like. Okay, so this is our data. It is read into the Jupyter notebook, and we are ready to work on this or analyze this data using scikit-learn functions. Okay, we are all set. We got the data onto the platform. All right. So next step, of course, you know, in data mining and analytics, data preparation is the important step. So we have got the data, but we need to look at the data, we need to categorize the data, and also this is a prepared data. There is isn't any missing data, there isn't any problem with the data set. This is for classroom work, and therefore you are getting a data set that is ready for exercise. Okay, so in the next cell I am actually extracting the y data or the target data. Okay, my y data is the bike buyer data. Okay, that is my y. Okay, so I am extracting it from the data frame data. And now you remember we called a function from scikit-learn, that is train test split. Okay, that function, you can use that function to split the data into train data and test data, right? And of course you have to specify arguments. Your arguments are the x is the attributes we already created, y is the target variable, and you have to specify what is your test size. Okay, and of course train size already get derived from the test size. Okay, and what does test size equals 0.33 mean? 33%, or 1/3 of the data will be used for testing. Okay, or 2/3 will be used for training. Okay, and random state equals 1 mean it will be picking 1/3 of the data randomly from the data set. If you make it 0, it won't be random. Okay. Okay, now let's build the model. Model building is fairly straightforward. You have to look at the manual, scikit-learn manual for decision tree classifier function. It will actually gives a whole description of arguments, as well as it also gives you examples. You know, you must be exploring that. Okay, but here we give certain so-called control parameters or hyperparameters. Okay, parameters that will control the processing of the algorithm. Okay, so one is, of course, you have to give the method for purity. Okay, or the measure of purity. Okay, and the criterion is that. Okay, so I am giving Gini. You remember we discussed what is a Gini score. Okay, you can choose entropy, or there are other measures as well. So let's use Gini, and then there are two hyperparameters or control parameters: minimum sample split 800 and minimum sample leaf. Okay, unfortunately in different literature and different software, okay, they use different terminologies that may often confuse you. Okay, some will call it bucket size. Okay, you may wonder what is a bucket size. Bucket size is the minimum leaf. Okay, minimum size of the leaf, I guess, in some literature. So 800 is the minimum size required for a node to split. If a node is less than 800, it will not split. Okay, that is that minimum sample to split. And 500 is the minimum size of a leaf or a child node. Okay, no child node will be formed which is, or no, sorry, not child node. No leaf node will be formed which is of size lower than 500. Okay, this is a specific input we are giving to the algorithm. Okay, so the algorithm has to ensure this is met when it actually runs. And we discussed all this. Yeah, it may not work, it may not split actually, because when it try to split, one of them becomes 200. Okay, so, or 300, etc. So it has to be minimum 1000. You know, you are right, it may not split. Okay, you can check when it actually gets formed. Okay, all right. And CCP Alpha, we discussed tree pruning in the class. Okay, and here is where we are applying it. Okay, CCP Alpha determines the growth of the tree. Okay, and if CCP Alpha is 0, what happens? Will the tree be large or would the tree be shrunk? Alpha 0 means the tree will grow to maximum extent. It is not stopped, it is not pruned. No pruning, that is what CCP Alpha 0 means. Okay, and the moment you put a value, it will try to drop leaf nodes and evaluate the performance and drop leaves if necessary. Okay, so we are starting with 0, we are letting the tree grow to its full extent. Okay, and you can see that dt is the name of the classifier. Okay, dt equals. Okay, so I am building a tree, I am specifying a tree. Okay, this is model specification. The first step is model specification, decision tree classifier, all the criterion I give. Okay, I am specifying. In the next step, I am fitting. Okay, you specified a model doesn't mean that the model is trained. Okay, in the next step, when you fit, the model gets trained. Okay, training has not happened, you are only specifying the model in the previous step. Okay, these are subtle things when you code, otherwise you get confused what is the difference between fit and applying the function. Okay, decision tree classifier you are applying doesn't mean that the model is built. Okay, model building happens in the last step when dt is fit into the data x train and y train. Okay, x train and y train. Okay, this is the data for x and y for training we extracted earlier. Okay, so this applies to general machine learning algorithmic programming in Python. Okay, when we use other examples also, I will not have to explain it again, but here we go. Now, one of the important steps for us now is to determine what should be the alpha value, right, CCP alpha, because we just put it 0, but we need an optimum CCP alpha. Okay, so one way to determine that CCP alpha is to do it empirically. Empirically means you don't derive any value, but you try different values, say from 0 to 1, and look at what point the error becomes least. Okay, the error becomes least. Okay, and use that CCP alpha, and that is what this particular cell is doing. Okay, I have given comments for most of the steps I have used there, so I don't want to into the details of it, but essentially this code is running or fitting data into the dt, which is the model that we have built. Okay, for different CCP alphas. Okay, and then check the errors. Okay, impurities here mean error. Okay, they have this interesting term impurity. Impurity means error. Okay, and then plot it. Okay, visualize it. Okay, let's see how it is visualized. Okay, so you can see that the x-axis is a range of alpha values. Okay, and y-axis is the corresponding errors. Okay, or impurities. And then you can see that when alpha value is increased from 0 to a higher value, of course it has not gone up till 1, but the trend is that as you increase alpha, the error is increasing or decreasing? Error is, y-axis is error. Okay, impurity is error. Okay, it is increasing, right? It is increasing, error is increasing, and therefore it is quite obvious from this that the lowest alpha is the best. Okay, for this model or for this problem. Okay, if you go to higher alpha values, the model error is only going to increase. So that's a input for us. So in the next level, what we do, we again specify the model, and then we fit the model with the alpha value 0, because we want to put alpha 0, which is, we already did this, we don't have to do it again, but that was a trial, but I am finally confirming an alpha value which is 0.0 based on sort of experiment we did.